Hi, I just wanted to make a quick video where I kind of go through the gateway. This is the in-person gateway that we did, not the practice gateway. This is the in-person gateway, um, and just show you my thought process for how to do each of these derivatives. So with the first one, we have a product of sine of x and ln of x, so we have to do a product rule. And then this is being subtracted from this, so I do this derivative separately from this derivative, and then I just, subtract or like add or whatever you want to call it, those two derivatives from each other. So let's do this one first. It's going to be a product rule. So product rule f prime g plus f g prime, that's the derivative of f times g, right? So derivative of the first times the second plus the first times the derivative of the second. Okay. So when I do sine of x, derivative of sine is cosine of x, and now I leave ln of x the same, and then plus sine of x times the derivative of ln of x. Derivative of ln of x is 1 over x. Okay. So I'm doing the derivative of the first, leave the second alone, and then plus leave the first alone times the derivative of the second. Okay. And then for this minus 4e to the 2x, so I still subtract 4 times blah, and so derivative of e to the something is e to the something, and then times the derivative of that something, right? That's the chain rule. So I do 4e to the 2x times the derivative of 2x, which is just 2. All right. Square root of x squared plus 1. Whenever I see a square root, I immediately either rewrite this or think of this as something to the 1/2 power. Okay, and then when I take my derivative of something to the 1/2 power by the chain rule, this is going to be 1/2 times something to the negative 1/2 power times the derivative of that something. Derivative of x squared plus 1 is just 2x, or like 2x plus 0, so I'll just say 2x. Okay. And then I subtract the derivative of cosine of x squared. Derivative of cosine is negative sine, so that'll make this positive actually. So positive sine. And then I keep the inside the same. And then I multiply by the derivative of the inside. Right, another chain rule going on here. All right, this last one I think is pretty difficult. Or next one, not the last one. So whenever you see something just like 1 over something, you want to think of this as that something to the negative 1 power. In the same way that like 1 over x is the same as x to the negative 1. If I have 1 over blah, this is equal to blah to the negative 1 power. Okay. If this was like 1 over e to the x times x cubed to the 5th, this would be e to the x times x cubed to the negative 5th. Right, same sort of concept. Okay. And so when I do my derivative, I'm going to bring that negative 1 down, the inside the same, negative 2. So I'm doing negative, so the derivative of something to the negative 1 is negative 1 times something to the negative 2, and then times the derivative of that something. Let's get rid of all this. So times the derivative of e to the x times x cubed. Again, this will be a product rule. So derivative of e to the x is just e to the x. Now I leave x cubed the same. Plus, now I leave e to the x the same, and take the derivative of x cubed, which is 3x squared. All right, now with d of x, I'm going to have to do a quotient rule. So I like to think of it as f prime g minus f g prime all over g squared. If you like the low d high thing, high d low, whatever, just do what works for you. This derivative, so I do derivative of the top times, and then leave the bottom alone. So derivative of 2 to the x is ln of 2 times 2 to the x. So the derivative of 2 to the something is ln of 2 times 2 to the something, and then multiplied by the derivative of that something, which is 1 over x. So that's my derivative of the top. And then multiply by the bottom, keep the bottom the same, minus, now we keep the top the same, and multiply by the derivative of the bottom, which is going to be 8 times the something to the 7th, and then times the derivative of that inside function, which is 2. Derivative of 2x plus 1 is just 2. Okay, now all of that is just going to be over the denominator squared. So this all squared. Okay. If you know your exponent rules, you would know that like something to the 8th and then squared, it could be written as this to the 16th power. I don't really care if you leave it like that or if you just leave it like this. Both are fine. Okay, done with quotient rule. With this is going to be just a chain rule. So derivative of something to the 16th power is 16 times something to the 15th power, and then times the derivative of that inside function. We need to have this all in parentheses here. So 2x to the 4th becomes 8x cubed. Square root of x, which is just x to the 1/2, becomes 1/2 x to the minus 1/2. And that, I believe, is our derivative, right? So that makes sense. Let's double check. Something to the 16, I get 16. Keep the inside the same to the 15. Then derivative of that is going to be 8x cubed plus 1/2 x to the minus 1/2. Yeah, this looks good. Now for the last one, it's going to be a product rule. Sine times 2 to the cosine of x. So again, derivative of the first, leave the second alone, plus the first, leave the first alone, and times the derivative of the second. Derivative of 2 to the something is ln of 2 times 2 to the something, and then times the derivative of that something. Derivative of cosine of x is just negative sine of x. And this is your derivative.